Welcome. Today, our focus turns to the constellation Cygnus. You likely know it as the swan, a familiar and elegant shape in our night sky. But we're going to explore it on a much deeper level, because Cygnus serves as a critical, and I mean critical, laboratory for some of the most groundbreaking discoveries in modern astrophysics. You see, this description isn't just poetic. Cygnus is far more than a beautiful pattern of stars. It's a dynamic region of space where fundamental discoveries have been made. A place that has profoundly and repeatedly transformed our very understanding of the universe. So, here's our roadmap. We'll start with the constellation's physical profile in space, then survey the incredible astrophysical objects it contains. After that, we'll delve into the breakthroughs and persistent mysteries it holds, examine its vast nebula and distant galaxies, and finally, we'll touch upon its rich footprint in human culture and mythology.
All right, first things first. Before we can appreciate what's in Cygnus, we need to establish its presence, charting its domain in the celestial sphere.
The sheer scale of Cygnus is substantial. It covers an area of 804 square degrees on the celestial sphere. That might just sound like a number, but it's large enough to rank it as the 16th largest of the 88 modern constellations. Now, to put that 804 square degrees into a more tangible perspective, it means Cygnus occupies nearly 2% of our entire sky. That is a significant piece of celestial real estate, especially for observers in the Northern Hemisphere. And due to its position, it's visible, either in whole or in part, to a vast majority of the world's population. For those of us in the Northern Hemisphere, it's a true hallmark of the summer and autumn skies. Its main star, Deneb, forms one corner of the very famous Summer Triangle, a key navigational landmark, alongside the bright stars Vega and Altair. Okay, so we've established where Cygnus is. Now, let's shift our focus to what it's made of. We're going to examine the incredible stars and systems within its borders, because this is where that idea of a cosmic laboratory really comes to life. Let's start with its brightest star, Deneb. This isn't just any star. It's an A2 class white supergiant. And to truly grasp its immense power, I want you to visualize our own sun. Now, imagine an object that shines with the light of 200,000 suns. That is the intrinsic luminosity of Deneb. It's almost difficult to comprehend. And what's truly mind-bending is that this immense power is coupled with a vast distance. At 2,600 light-years away, Deneb is the most remote first-magnitude star visible to the naked eye. Think about that. The photons of light from Deneb that are striking your retina tonight actually began their journey when Earth's Iron Age was in full swing. Now, in stark contrast to Deneb's solitary, overwhelming power, we have Albireo. This system beautifully showcases the elegance of binary stars. Point even a small telescope at it, and you'll resolve it into two distinct points of light, a brilliant golden-orange primary star right next to a vibrant sapphire-blue companion. The color contrast is absolutely stunning. This patch of sky has been the stage for discoveries that fundamentally reshaped our cosmic address book, and, indeed, our understanding of physics itself. And you know what? It continues to present us with some of the most profound puzzles in astronomy today. Two historic moments really stand out. First, back in 1838, Friedrich Bessel used the star 61 Cygni to make the first ever successful measurement of stellar parallax. This was a monumental achievement. It gave us our first accurate distance to another star. Then, jump forward to the 1970s, and Cygnus X1 becomes the very first object to be identified and confirmed as a black hole. So how do we see an object that, by its very nature, is invisible? This is the beautiful, violent mechanism at play in Cygnus X1. We don't observe the black hole directly. What we witness is a cosmic drama. A massive blue supergiant is locked in orbit with an unseen partner, and its material is being siphoned away by an immense gravitational pull. This stolen gas forms a swirling, superheated accretion disk that, as it spirals toward oblivion, heats to millions of degrees and blasts out powerful X-rays. That X-ray signal, that's the smoking gun. Now, moving beyond individual stars, Cygnus is also home to vast interstellar structures. We're talking about the birthplaces and, indeed, the graveyards of stars, as well as some of the most powerful distant galaxies known to us. Take the Veil Nebula. This is a ghostly testament to stellar death. Imagine a star, many times more massive than our sun, exploding in a supernova. What we see today is its aftermath. an intricate, expanding shell of glowing gas filaments that looks like delicate celestial lace. This explosion happened over 5 millennia ago.
And then we have a fantastic case of cosmic pareidolia, the North America Nebula. This is an enormous star-forming region, a vast cloud of ionized hydrogen gas. And what's remarkable is that intervening dark dust lanes create a silhouette that is just unmistakably similar to the continent of North America here on Earth.
And finally, there's Cygnus A. If you look at it in visible light, it's pretty unremarkable. But if you tune your instruments to radio wavelengths, it becomes one of the brightest objects in the entire sky. This is an active radio galaxy, 600 million light-years away, whose central supermassive black hole is ejecting colossal jets of plasma out into space. It's a prime target for radio astronomy.
So, for our final section, let's step back from the astrophysics and examine the rich tapestry of human imagination. We'll look at the myths and historical interpretations that cultures all over the world have woven around this distinct pattern of stars.
It's really fascinating. The ancient Greeks had multiple stories, seeing it as Zeus in disguise as a swan, or the devoted king Cygnus. Arabic astronomers saw the hen's tail, or Deneb al-Dajaja, which is where the name of its brightest star, Deneb, comes from. And in Chinese mythology, the stars of Cygnus play a supporting role, forming the Magpie Bridge that appears once a year to allow two celestial lovers, represented by the stars Vega and Altair, to be reunited. So you see, Cygnus truly is a bridge. It connects ancient poetry with the bleeding edge of 21st century science. From myths of gods in disguise to the hard X-ray emissions of a black hole, it continually invites us to look deeper. And that leaves us with a final, provocative question. Within this vast, rich cosmic laboratory, what fundamental law of the universe will be discovered here next?